Okay, the last thing from section 3.1. So just like with lines, we introduced lines, we solved equations of lines, we graphed lines, and then we did linear regression of lines. And so we're going to do something similar here with quadratic information. We're going to do quadratic regression, meaning our data is going to follow the path of a quadratic versus following a path of a line. And it's all done on the calculator. All right, so the following first one, quadratic regression, the first table in the notes, represents the weeks since an ad campaign started, so the first line are the weeks, and then the sales, auto sales, all right, after they started their campaign, all right, auto sales. Find the quadratic model that best fits to estimate the sales after 1.5 weeks. Look at the graph and plot the point. So you can see that it does model a quadratic. And so again, this is all done on the calculator, similar to what we did with the linear regression. The difference is we're going to do quadratic regression. And so it's all done in the stat key on the calculator. So you go to stat, you pick edit. That's the first thing. List 1 are your X values, which are the weeks. List 2 are the Y values, which in this case are the sales, right? Because the sales depend on what week into the campaign you're in. All right, so again, X is your independent variable, Y depends on what X is. All right, sales depends on what time we pick. And so that's the very first thing we do. So we're going to go into the calculator. So you're going to go into the stat key. You're going to pick edits. If you have anything in your list, clear them out. And then list 1. So you remember you highlight it and then hit clear. So list 1 are going to be the weeks 0 through 4. List 2 are our sales, which again paired with each of the weeks. So 28 goes with 0. Then 38, 45, 48, and 46. Quick double check, make sure I typed them in right. So 28, 38, 45, 48, 46. And then we're going to go back to the stat key. Then you're going to go over to calculate, and it's right under the linear regression. I want quad regression. That's quadratic regression. So it's the fifth one down that I want to pick. Quad regression. So hit enter. All right, double check to make sure. If yours is an older model, it won't pop this up. It'll just do quad regression on your home screen, and you should be good to go. The default should be the X values are list 1, the Y values are list 2. If yours is newer, like mine, make sure there's nothing in the frequency, nothing in the stored. So make sure those are hit clear if there's something in there. All right, those need to be blank. You only need the X values in list 1, the Y values in list 2, and then you hit calculate, and it gives you your quadratic. A is the term that goes with, so A is -2, it goes with the square term. B is 12.6, it goes with the X term. C is 27.8, and the R does have to do with how good it fits. All right, so the R has to do with 0.9998. Again, you want it to be close to 1, and it is. 0.998 is pretty darn close to 1, so it's a pretty good fit, and we'll see that when we go to graph it. Alright, so once you've typed those numbers in, you go back into stat, over to calculate, and then it's the fifth one down. It's the quad regression, right? Quadratic regression. And then it gives you your quadratic equation that models this. So it came out. -2 was the A term with the square. 12.6 was our B term. And 27.8 was our Y term. All right, and so there's the equation that best fits this information. Again, it's a pretty good fit because the R came out almost 1. All right, so once we find it, then we use it. So I want to estimate. So again, they gave me the sales at the beginning of each week. So we want to know, well, what were the sales between week 1 and week 2? So at about 1.5 weeks, what were the sales? And so we're going to plug this in. That's my X value. So I'm going to find f of 1.5. I'm plugging it into this equation to figure out what their sales were in about 1.5 weeks. All right, it comes out to be about 42.2, so 42 would be the auto sales. Or approximately, since we did round. All right, now I'm going to look at the graph and show you that these are again, modeling a quadratic curve. So we're going to do a stat plot like we've done stat plots before, and then we're going to graph this line with our stat plot. So remember, when we turn plots on, remember to turn them off after we do it. And so I'm going to go back into my calculator. Go into stat plot, which is second. The y equal to, which actually I already have it on, but if yours should be turned off, go ahead and hit it on. Alright, make sure it's the type with just the dots. We only want the dots. List 1 should be L1. List 2 should be Y values. And again, that's just the shape that comes up. Before I get started, though, I am going to change my window because my points are going to be... Alright, which again, it probably looks like I already had a window here set up. So remember, the X values go from 0 to 4, so I need to make sure I can see 0 to 4. I went -2 so I could see my axes, so -2 to 10. And then the sales were the Y values. The biggest sale was 46. I need to make sure I go beyond 46. And so my Y value is 60 here. And I scaled by 5, so I have dash marks every fifth one. And again, I put my minimum of -5 because I wanted to make sure that I could see... I like to see the X-axis and the Y-axis. And again, that's just a personal preference. Should be good to go. Should plot the points. So I hit graph. Alright, so there's the points. And if you look at it, it's not so much easy to tell right now that it is the quadratic case. Alright, it looks like it could be almost linear, but if you actually tried to solve this with linear regression, you'd find that the R is very poor. I think it's like 0.7 or something like that. So now I'm going to plug in my equation I have, and we'll see that the path that it does take is the quadratic shape, and it almost fits it perfectly. So I'm going to go type in my quadratic I found, which remember was -2 x squared plus 12.6x plus 27.8. Graph, and it'll graph. So there's that quadratic. And you look, 3 of the points look like they fit exactly on it, right? The first, the second, and the last point. And then the 2 in the middle, they look like they're slightly off, but just barely off my quadratic. And so it's a pretty good fit. It does follow the path of a quadratic, at least for the first 5 points in this case. And there's the quadratic again. So again, it's a pretty good match. All right, the second example. Alright, heart rate of athletes. While training is recorded for 4 minutes, the table gives the list of the heart rate after X minutes. So X represents the heart time in minutes. Y represents the heart rate. Alright, so 84 beats per minute. BPM, beats per minute. Right, find the quadratic equation that best fits the data. What's the domain of the function? What's the person's heart rate after 2.5 minutes? Does the graph open up or open down? Alright, so we just want to find the best fit. So again, it's a quadratic. So we want to do a quadratic regression. So make sure you go in and pick quadratic regression. And so I'm going to go in and plug it into the calculator. So I'm going to turn my stat plot. Actually, I'll do it later. I'm going to go into stat, edits, clear my list. Actually, I could have left that list because it's the same values, but I'm going to re-plug them back in. Just always get a roll of thumb to clear them and plug the new information in. And then the heart rates. So the heart rates were 84, 111, oops, 84, enter, 111, shoot, 120, 110, and 85. Alright, then go back to stat, go over to calculate, and again we want to do the quadratic regression. We want to pick 5. It should be the same as before, so you shouldn't have to change anything there. Hit enter. And this one's a little uglier, so my rule of thumb, but it's still a pretty good fit. If you look down here at 0.9988, that's a pretty darn good fit. My rule of thumb, so that you're not significantly off, I'll usually round 4 decimal places. So that's what I'm going to do. I'm going to write out my A and B and C. And again, be consistent. So if you round 1 to 4 decimal places, round them all to 4 decimal places. And that's, again, that's my rule of thumb, so I'm not going to be significantly off in my rounding when I get to my final answer. Alright, so my quadratic equation is x squared goes with the A term, which was -8.7857 x squared, My B was 35.2429x, and my C was 84.2286 if I round 4 decimal places. All right, so there is my quadratic equation. It's a negative, so I actually already know it's going to open. It would open down if we graphed it. You can graph it and double check that it does. In this case, we don't need to graph it, but you could if you wanted to. It would be a graph that would open down. All right, so there's the part one. All right, what's the domain? The domain actually goes with the given information. All right, whenever you're given statistical information, the domain is what you have. So the domain for this function are the values, the time. They only recorded the time between 0 and 4, right? That's when they recorded the time, and so that's when this equation works. It works over the 0 to 4 range, or the 0 to 4 domain. And so the domain would be 0 to 4 and every time in between that. Right, so that's the domain of this function. What's the person heart rate after 2.5 minutes? So that's just take my 2.5 and plug it in there. So again, what's the y value when x is 2.5 minutes? And so it's just make sure you're careful. It is a bit messy because you've got all those long digits. So just carefully type those out. When you do, you should get the heart rate comes out 137.12 in beats per minute. All right, which should make sense. It's between the 2 and the 3, so it means the peak is a bit high. So it means the peak's probably somewhere there in between 2 and 3. And so there is our beats per minute between 2.5 minutes after we started the exercise. We already did the concave down, and so that's an example of quadratic regression. Again, it's similar to linear regression, except it's a quadratic format. All done on the calculator. All right, stop there. That finishes up 3.1.